Just to introduce myself really quickly, I'm Mike Schwartz. I'm the founder and CEO of Glue. Glue is a software vendor. We make something called the Glue Server. It's an open source identity and access management platform. We also make the SuperGlue two-factor mobile app and an API gateway for API security. So if you want to follow us on Twitter, we're at Glue Federation, and on LinkedIn, you can just send me a LinkedIn to NY Mike. So it's going to apparently flip in and out, so we'll just keep our fingers crossed. So I wanted to sort of reverse this. So this is a talk on single sign-on, SAML, OpenID Connect, OAuth, and I thought instead of me maybe talking at you for 45 minutes, but just to get it out of the way, we'd reverse this, and I'd take questions first, and then do the presentation after. So maybe if anyone is coming into the session and has some questions about single sign-on, OpenID Connect, SAML, OAuth, any of this stuff, any questions like before we start? Claire?
So my question is about market share and adoption. And I don't need exact numbers, but in terms of SAML versus OpenID Connect, et cetera. Talk a little bit about what's being used and a little bit about how you would forecast the adoption rates.
Okay. Any other questions? So if you just came in, we're doing a reverse session. I'm taking questions about SAML, OpenID Connect, and OAuth first, and then I'm gonna do the presentation. Right in here in front.
I'm going to be the noob and say I don't know what the differences are.
Okay, so what are the differences between all the above? Yeah, we're definitely going to cover that. In the corner?
Yeah, when you're looking for clients on what to implement, what should you be looking for as a basis? Like, this will work better with this kind of environment, this will work better for that kind of environment.
Okay, so if you're a developer and you're writing software and you need to know what client software you use to connect to OpenID Connect server or a federated identity server. Okay, cool, that's good. In the front? Mm-hmm. So which is more secure, SAML, OpenID? Okay. Okay, so SAML was okay. Why are we using newer protocols, and what's the security benefits, pros and cons for each? I got you. Okay. One in the back?
What are some of the, how to kind of like audit for some of the implementation issues when it comes to these two protocols?
How do you audit the SSO and transactions?
So to look at implementation issues,
Okay.
code level implementation issues with one of these protocols from security vulnerabilities, that's probably the word audit, but I'm trying to say that more absent from that.
Okay, so audit and application security implications for the federated identity. Yeah, in the front.
Which protocol is better for cloud?
Okay, which protocol is the best for the cloud? Okay, these are all good questions. It's amazing how many questions people have about federated identity, and they ask them a lot of different ways. So, okay, so that's helpful for me to understand where you're coming from. So let me just start with like the really most basic point I can make, which is that the reason that we use federated identity is because we don't want to show the password or expose the secret to the client. So we have two actors here, the client and the server. The client is the thing that's connected to the person, and the server is the thing that's holding the secret, think password. And what we really don't want to do is have the person enter, let's just say, the secret, like the password, into the client. Because if the client sees the secret, then the client can impersonate the person, the human, and that's not good. So let me try and... so that's the point. So I'm just going to give the whole talk away and just tell you like the answer in the third slide. Um, in the 90s, we had these authentication protocols like Radius and LDAP, and they ran on a specific port, and we had, their own IETF drafts for these things. And around maybe, late 90s, 2000, somebody said, maybe we should just use the web as the transport layer for authentication. And that way we won't need to define our own port, and we have all this stuff in use in the web anyway. And I think everyone agreed that was sort of a good idea. But then once we said, let's use the web for authentication, everybody and their brother thought of a different way to use the web for authentication. So in the early 2000s, there was this explosion of like protocols for single sign-on and using the web for authentication. So in the mid-2000s, SAML became sort of an agreed-upon standard between a lot of different organizations, like the big companies like Oracle, even Microsoft. And then, unfortunately, in 2007, this important thing happened called the iPhone, and all of a sudden, we had a whole new paradigm of mobile apps calling APIs that just didn't really exist. The SAML and these previous protocols were built for like a person using a web browser going to a website, and mobile sort of like just disrupted the whole thing, like created all these use cases that SAML wasn't made for. What happened was that it wasn't just that that we wanted to invent a new protocol to replace SAML, but there were actually new requirements. So the SAML being a stable spec couldn't be changed. So to meet these new requirements and this increased surface area, we basically needed to either improve SAML or to invent something new. And improving SAML was not possible because it is what it is, and the vendors wouldn't accept any breaking change. So there was really no choice except to move to this new profile of federated identity. Around the same time that was happening, there were some other just dramatic shifts in the sort of web development world. So we went from being let's say XML centric to being JSON centric. I just have to find my slides. Okay, found them. And in general, there was also a movement around being more developer friendly. So when SAML was first designed, it was sort of top-down security. Here's the security that you need to do, developers. You will all do it. But sometime around, let's say, the late 2000s, Google and others were saying we have to listen to what the developers are saying and make our APIs developer friendly. Okay, so let me see if I missed anything. Signing. So in SAML you use you canonicalize the XML. That means you make two pieces of XML with different white space the same, and then you sign it. OpenID Connect uses a different JSON-based signing mechanism. Another interesting comparison is that now there's a lot of esoteric SAML that no one ever uses, but artifact binding is one of them in SAML, but there's actually an exact equivalent in an OpenID Connect. The code is used in SAML would be artifact binding. So it really is a direct parallel between SAML's an identity layer using XML and OpenID Connect is an identity layer using JSON. I talked a little bit about, so SAML, this is sort of SAML 101 stuff, but a SAML profile takes a number of these different concepts and creates different ways that you could use SAML. I'm going to skip through this one because we're behind on time. The basic idea with SAML is that you're bouncing an XML file back and forth using the user's browser. So there's a SAML request that gets sent from a website. I want to authenticate this person. The SAML server gets that XML, and then it authenticates the person and returns an XML back to the website and says, here's who this person is, here's your SAML assertion. It's a neat trick because the IDP and the RP don't have to be connected. As long as the person's browser can reach both, it's okay. And SAML basically working, and secure if you're using, web applications. It's really those new applications, JavaScript and mobile, that just were totally unaccounted for in SAML use cases. So there's a fair amount of confusion about OAuth and being an authentication protocol. So OAuth is actually a mechanism to enable a person to authorize something. This is sort of a saying, but you can have using chocolate to make fudge does not make chocolate equal fudge. So using OAuth for authentication, doesn't make OAuth an authentication protocol. If you read the IETF draft, the OAuth spec actually says it's an authorization framework. Note, not a protocol either. A protocol is much more specific. OAuth uses tokens. There's two different types of tokens. Bearer tokens is just some type of unguessable string, and you put that sort of into your request. It's really handy. And then a JWT is really an assertion. It's a JSON that includes a signature, and it could potentially be encrypted too. So OAuth defines a couple of roles. Really, the three in the middle are the ones you need to think about. There's a client, a resource server, and an authorization server. The client is the thing that's connected to the person. That's either your mobile app or your website. The resource server is the API. So you might have a mobile app, you authenticate, and then your app starts calling APIs on your behalf. So the resource server is the API server. And the authorization server is the thing that issues tokens. So those are the three actors in OAuth, and those are the same across all OAuth profiles. We have some other people who are in this. We have developers. The requesting party would be the person trying to get access to the thing, and the resource owner is the person who controls the thing. So you probably, from the user perspective, you've used OAuth. So this is an authorization request from Google. Google, you can see, it's too small to see in the URL, but actually OAuth 2 is in the URL. So Google's saying, can this application CNET, what do they want to do? They want to see my age and language. So it's an explicit consent by me. This is a nice trick that was hard to do in SAML. So OAuth defines these things called scopes, and each scope maps to some permission or some permission description you might want to display to the user. So if we had a scope called calendar, we might want to send a message to the user that says this app is going to update your calendar. So OAuth uses scopes to sort of map authorization policies. This page that I'm referencing, Google publishes a list of basically every scope that's needed to call every API. And sometimes an API might have varying levels of granularity with what function within that API are you trying to call. OAuth, you might have heard of these things called grants. A grant is a flow. You would have a different flow for, let's say, a client that's just doing client authentication. Think of an IoT device that's calling an API. There's no person in that loop. We have this device calling an API. So that's one flow. We have a flow where the person's using a browser We have a flow where the person's using a JavaScript application, and OAuth even defines this flow you're not supposed to use called the resource owner password credential grant. That's where the client actually has the password and wants to validate it. So grants, really, you can think of them as different flows. So what's interesting about, people think of SAML as being, really a big spec, but actually people don't use 90% of SAML, so the 10% that people use is actually really short, and OAuth has gotten way bigger than SAML. Currently 16 RFCs and 16 draft RFCs. It's covering a lot more of these. Basically, as new vulnerabilities are announced, mitigations are published and standardized. And so, basically OAuth is just covering all these new use cases that we need to cover. So what's interesting is that with all of these specs in OAuth, you won't find anyone that talks to you about how to do user authentication. So there's no equivalent of SAML in these OAuth specs. Ironically, the OAuth group didn't want to take that on, and so they used the OpenID Foundation to create a profile of OAuth 2 that serves as an identity layer like SAML. So really, you could take the 16 draft RFCs, or the 16 RFCs and the 16 drafts, and then add an additional probably 6 or so from the Jose group. That's the JSON object signing and encryption, and then probably another 6 specs from OpenID Foundation, and you sort of get one body of like what's the current state of like of authentication and federated identity. Connect has 3 main specs. One is quote core, and that explains how do you authenticate a person. One called discovery, that's the equivalent of SAML metadata. So a SAML metadata is like an XML document describing the services and the keys of the entity, the IDP or the SP. SAML or OpenID Connect has a well-known address that's standardized that returns a JSON object that tells you who is this IDP and what crypto does it support and where are its keys and what are the URLs for its different services. And client registration standardizes OAuth clients used for authentication. So OpenID Connect is OAuth 2. It profiles OAuth 2. So it adds in more details to create a user interoperable implementation of OAuth 2 for identity, for both authenticating the user, but also for sharing information about that user from the IDP. So what people get confused is they say, well, we have these 3 actors in OAuth, client, authorization server, resource server. We only have 2 in SAML. We have the IDP and the SP. So what happened? Well, what happened is that the thing that we call the OpenID provider is actually smushed together the RS and the AS in one unit, because it's both issuing the token and serving up the resource, called the user info endpoint. That's where we give up who is this person. So just walk you through like the difference between a JavaScript app and a server-side app. There's one huge important difference, and that is that there's no client credentials. If you're using a JavaScript app, you redirect the person to the identity provider, the person authenticates, you get back a token. But nowhere in that do you present your client secret. You tell the server who you are, which JavaScript app, but you don't present any secret. In the code flow, which is used for if you have a Spring app or a Ruby on Rails app, then you're using a server-side app where the code is on the server. In that case, the server can protect a secret, so the server can use either client ID and secret, we see used a lot in OAuth, but potentially you could also use private key authentication. OpenID Connect defines an asymmetric authentication mechanism for the client, so that it doesn't have to have a shared secret with the server. So I think that pretty much covers it. Let me go back to the questions and see if I can. So one of the questions, Claire's question was about relative adoption of the protocols. So that's a really good question. The adoption of the protocols, I would say, your enterprises, large enterprises today are most likely to have SAML. If they have an older version of Active Directory, they might have Active Directory Federation services. Popular SaaS services like OneLogin, Okta, and Ping One are all using SAML and only sporadically supporting SAML. SaaS services are mostly supporting SAML. So on sort of the enterprise, type application SSO front, SAML is pretty prevalent. However, if you talk to developers who are writing new applications, then it's almost like 100% OpenID Connect. Like nobody wants to write any new SAML apps. So new SaaS providers who are just launching are griping about supporting SAML, and application developers who are doing consumer-facing applications or internal-facing applications, they don't want to mess with SAML if they don't have to. So if you're writing an app, you want a JSON REST API. You don't want a big XML thing to parse and canonicalize. The other question was about client software. So that's a really interesting question. There's quite a bit of client software out there. I look at it as we have plugins for web servers is one category, and then we have libraries. In the plugins for web server side, OpenID Connect has plugins for Apache and Nginx. SAML, there's Apache. I'm sure there's an Nginx one out there too, but I know Apache and IAS. There's a couple of proxies that support OpenID Connect. I know the Kong API gateway supports it if you're looking for a web proxy for that. On the client software side, OpenID Foundation has a client certification program, so libraries can get certified. And there's basically client libraries for everything. Like you can go to GitHub and you can find Ruby, JavaScript, Node, Go, like whatever your programming language is, there's an OpenID Connect library for it, which brings up an interesting security challenge for organizations, which is if my developers are using a bunch of different libraries we grabbed off GitHub, how do we know that if some security vulnerability is announced in OAuth, that we can patch that library? And if we patch the library, do we have to re-QA the app? Glue has introduced some client middleware called OXD, which is shareware licensed, that it runs as a service, either a central web service or as a service for listening on localhost, and enables you to update the software using apt or yum, and then keep the application interface stable. So there's a bunch of approaches in client software. I have another talk where I just talk about how to write secure client software. And the one thing I'll say is that if you have a really good server like the Glue server or Ping, and you do a really bad job like writing a client and you don't validate the state and you don't validate the signatures, and you just sort of like, oh, there's a JSON with the person's information, I'll grab that and create my session. You can totally undermine the security of any authorization server if you write a bad client. So that's an area that people don't think about a lot. Somebody had a question about audit and basically how do you, I would just say in general in an SSO system, there could be hooks to certain important events. And I think when you're evaluating like a platform, one of the things you should look at is how easy is it to customize? Does it mean I have to fork the code and manage my own distribution? Or are there convenient interception points that allow me to maintain my customizations in a standard way? So in terms of telemetry, like what telemetry is thrown off by the server varies greatly depending upon the distribution. It's not really a protocol specific thing. And it's hard to find data on like what should you even be looking at. What's unusual? What do you want to log? So it's sort of like an area where I think a lot of companies just are looking at traditional web telemetry type of information. So in front, we had a question about security. Well, it depends. It's not a question of is it secure or is it not secure? Because there are different. The question is it secure enough for the transaction that you're undertaking? OpenID Connect philosophy was to keep simple things simple, but to make more advanced things possible. If you take the JavaScript flow that we were talking about, the implicit flow, not terribly secure, but totally appropriate for lots of types of transactions. But if you look at the new profile that was developed for banking, called FAPI, the financial APIs, that aligns with PSD2, they used every security feature known to man and then a couple, and it's actually, if you do all that stuff, it's way more secure than anything we're doing today. You can actually rate the flows from 1 to 5 in terms of security. So plain OAuth by itself would be 1, the worst. And then implicit flow would be number 2. That's the JavaScript one. It's actually better than OAuth by itself, because OAuth just gives you the state, and that's it. Implicit flow gives you the ID token, so you have a signed assertion. Then you have code, which is better because you can do client authentication. And there's 2 above code called hybrid. One hybrid flow above includes signed responses. So the code itself can be hashed and signed. So there's some extra security hoops you can go through above code. And then there's a second hybrid flow which involves request signing. So when you send the request, that itself can be signed, so that the IDP knows it came from the client. And then there's they went to create a complete security profile around all of how you use all this stuff. And to have it standard and interoperable is really difficult, and that's why they took that on at the OpenID Foundation with the financial APIs, because in Europe the PSD2 regulations specify these APIs for basically transacting payments. And they specify the security around it, and the profile sort of aligned to the requirements set forth in PSD2 for the practices and procedures and that you need to do to both the client and server side need to do. Okay. Well, everyone in the OAuth community knows that this is their it has a specific use case. In a trusted network, maybe there's a use case for it. We always say don't use it. It's not an SSO protocol anyway, because SSO protocol always involves a redirect, so we can keep the session in the browser. And it is, you're right. But the resource, you know what? You can go through the OpenID Connect spec, and you can find stuff about like autonomous IDs and delegated attributes that'll never be used, but they're not taking it out either. There's the best practices that have emerged around the use of OAuth, some of which is published as RFCs. There's a really good RFC around best practices for mobile OAuth 2, written by Google and others that you should read. And it basically suggests the use of a protocol to enable almost like a one-time secret to be generated rather than using client credentials, called PKCE. There's a ton of best practices around it, and also remember that the federated access protocol is how we send information about who authenticated to the app. There's another super important part about how did we authenticate the user in the first place, and how did the identity and other stuff get granted. Yeah, so there are various ways you can impersonate a user. If you can intercept any of these pieces that flow back and forth between the client and the server, you could potentially impersonate somebody. And fraud detection is, I think, is really important to do at authentication time. But just talking about outright hacking, if you didn't protect all of the communication between the server, let's say the authorization server and its database, and the client and the server, the assumption for all of this stuff is that there are secure communications between the pieces. But if you could intercept a code or a token, you potentially could impersonate a user. But delegation to a customer service rep, it's really sort of an implementation detail of how do the application's going to support that and how are you going to make that happen. But so does everybody know why they wouldn't use LDAP for authentication? Anyone still using LDAP for centralized authentication for web apps? Okay, yeah. And what are I guess I can give my last slide. So the glue server, if you want to try out OpenID Connect or SAML, you can go to glue.org. If you want to get these slides, I created a short link, glue.co, LASCON 2017. Note there is glue.org. We just use that glue.co for short links. So there is no glue.co. But we're glue.org. Glue is it's open source. It's free open source. So we have packages for Debian, Ubuntu, CentOS, Red Hat. You're basically doing a yum install glue server, and then you run a setup script, and you have a local instance deployed. It deploys on the cloud, etc. The clients I recommend, if you just want to get started in figuring out, like, hey, how could we do federated identity? You want to write a test client if you're a developer. The one I suggest is the Apache filter for OpenID Connect. It's called mod-auth OpenIDC. If you just want to say, I have a website in Apache and I want to protect this website, with my central OpenID provider, that's probably one of the easiest tests to do. Glue also has a JavaScript client that's pretty easy. You can do the authentication all in without any coding, just all in the HTML. And feel free to send me a LinkedIn also. So we either follow us on Twitter, go back to that. We post a lot of good stuff. We post not just stuff about Glue, but we also post every industry news piece relating to authentication. Like if there's elbow authentication in the future, we'll be tweeting about it first. We generally tweet out, if you're looking what are the latest RFCs, IETF, like drafts, etc., we tweet that out, and then a bunch of industry articles, and occasionally a Glue blog, which we don't write enough of. And if anyone needs more info about Glue, everything on the Glue site funnels you to schedule a meeting, so feel free if you think you need more info, just let us know. Okay, thanks everyone. Go to lunch.